Hello friends. Welcome to Basics of Cloud Computing tutorial. I am Bhargav. In this video we will see what is cloud computing. At first let me start with some introduction. The concept of cloud computing can be very confusing. In this video, we'll start by giving you a general overview of the cloud and the concepts associated with it. Then we will discuss some of the factors that are driving organizations to the cloud. We will close by taking a look at some of the issues that are preventing an even greater shift to the cloud. Now let's see. What is the cloud? There has been a lot of debate about what the cloud is. Many people think of the cloud as a collection of technologies. It's true that there is a set of common technologies that typically make up a cloud environment, but these technologies are not the essence of the cloud. The cloud is actually a service or group of services. This is partially the reason that the cloud has been so hard to define. Originally, the cloud was thought of as a bunch of combined services, technologies, and activities. What happened inside the cloud was not known to the users of the services. This is partially how the cloud got its name. But that definition has since changed. Providers have realized that although some users won't care about what is going on behind the scenes, many actually do care. This user interest prompted providers to be more forthcoming about what they are doing. In many cases, customers are even allowed to configure their own system monitoring solutions. As with all services, the cloud and the services it offers have changed over time. Most services change very quickly to adapt to customer needs. Think about it, which services, especially technology-related services, have you used that have not changed over time? Not many, right? If you are a service provider, you have to modify and fine-tune your services in order for them to remain relevant and valuable to your customers. Well, the cloud is no exception. This is where the confusion came in. Each time someone came up with what they thought was a good definition, the services changed. Many thought that once the National Institute of Standards and Technology, NIST, came up with a formal definition for cloud computing, that would be the final word. But, as we have seen, even the NIST has changed its definition over time. Even with the changes, the NIST definition still remains the standard most people refer to when talking about the cloud. The NIST cloud definition has three main components that we will discuss. 1. 5 key cloud characteristics. 2. 4 cloud deployment models. 3. Cloud service models. Now first we will see the 5 key cloud characteristics. A lot of companies and services providers have been trying to cash in on the popularity of the cloud. Many providers claim to offer cloud services, even though they really do not. Just because an application is web-based does not mean that it is a cloud application. The application and the service around the application must exhibit certain characteristics before they can be considered a true cloud implementation. The NIST definition of cloud computing outlines 5 key cloud characteristics. On-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. All 5 of these characteristics must be present in order for the offering to be considered a true cloud offering. On-demand self-service. On-demand self-service means that a consumer can request and receive access to a service offering, without an administrator or some sort of support staff having to fulfill the request manually. The request processes and fulfillment processes are all automated. This offers advantages for both the provider and the consumer of the service. Implementing user self-service allows customers to quickly procure and access the services they want. This is a very attractive feature of the cloud. It makes getting the resources you need very quick and easy. With traditional environments, requests often took days or weeks to be fulfilled, causing delays in projects and initiatives. You don't have to worry about that in cloud environments. User self-service also reduces the administrative burden on the provider. Administrators are freed from the day-to-day activities around creating users and managing user requests. This allows an organization's IT staff to focus on other, hopefully more strategic, activities. Self-service implementations can be difficult to build, but for cloud providers they are definitely worth the time and money. User self-service is generally implemented via a user portal. There are several out-of-the-box user portals that can be used to provide the required functionality, but in some instances a custom portal will be needed. On the front end, users will be presented with a template interface that allows them to enter the appropriate information. On the back end, the portal will interface with Management Application Programming Interfaces, APIs, published by the applications and services. It can present quite a challenge if the backend systems do not have APIs or other methods that allow for easy automation. When implementing user self-service, you need to be aware of potential compliance and regulatory issues. Often, compliance programs like Sarbanes-Oxley, SOX, require controls be in place to prevent a single user from being able to use certain services or perform certain actions without approval. As a result, some processes cannot be completely automated. It's important that you understand which process can or cannot be automated in implementing self-service in your environment. Broad network access. Cloud services should be easily accessed. Users should only be required to have a basic network connection to connect to services or applications. In most cases, the connection used will be some type of internet connection. Although internet connections are growing in bandwidth, they are still relatively slow compared to local area network, LAN, connections. Therefore, the provider must not require users to have a large amount of bandwidth to use the service. Limited bandwidth connections lead to the second part of this requirement. Cloud services should require either no client or a lightweight, thin client. First, downloading a fat client can take a very long time, especially on a low bandwidth connection. Second, if the client application requires a lot of communication between the client system and the services, users may experience issues with latency on low bandwidth connections. This brings us to the third part of this requirement. Cloud services should be able to be accessed by a wide variety of client devices. Laptops and desktops aren't the only devices used to connect to networks and the internet. Users also connect via tablets, smartphones, and a host of other options. Cloud services need to support all of these devices. If the service requires a client application, the provider may have to build platform-specific applications, i.e., Windows, Mac, iOS, and Android. Having to develop and maintain a number of different client applications is costly, so it is extremely advantageous if the solution can be architected in such a way that doesn't require a client at all. Resource pooling. Resource pooling helps save costs and allows flexibility on the provider side. Resource pooling is based on the fact that clients will not have a constant need for all the resources available to them. When resources are not being used by one customer, instead of sitting idle, those resources can be used by another customer. This gives providers the ability to service many more customers than they could if each customer required dedicated resources. Resource pooling is often achieved using virtualization. Virtualization allows providers to increase the density of their systems. They can host multiple virtual sessions on a single system. In a virtualized environment, the resources on one physical system are placed into a pool that can be used by multiple virtual systems. Rapid elasticity. Rapid elasticity describes the ability of a cloud environment to easily grow to satisfy user demand. Cloud deployments should already have the needed infrastructure in place to expand the service capacity. If the system is designed properly, this might only entail adding more computer resources, hard disks, and the like. The key is that even though the resources are available, they are not used until needed. This allows the provider to save on consumption costs, i.e., power and cooling. Rapid elasticity is usually accomplished through the use of automation and orchestration. When resource usage hits a certain point, a trigger is set off. This trigger automatically begins the process of capacity expansion. Once the usage has subsided, the capacity shrinks as needed to ensure that resources are not wasted. The rapid elasticity feature of cloud implementations is what enables them to be able to handle the burst capacity needed by many of their users. Burst capacity is an increased capacity that is needed for only a short period of time. For example, an organization may need increased order processing capacity at the end of the fiscal quarter. In a traditional environment, an organization would need to have internal capacity to support this load. Most likely this would mean that there are resources that are always available but are only used a fraction of the time. In a cloud environment, an organization may take advantage of public cloud resources for that short period of time. There is no need to have that capacity always available internally. Measured service. Cloud services must have the ability to measure usage. Usage can be quantified using various metrics, such as time used, bandwidth used, and data used. The measured service characteristic is what enables the pay-as-you-go feature of cloud computing. Once an appropriate metric has been identified, a rate is determined. This rate is used to determine how much a customer should be charged. This way, the client is billed based on consumption levels. If the service is not used on a particular day, the customer is not charged for that time. If you are paying for cloud services, you need to make sure you understand exactly which services are being measured and charged for. In a measured service, it's very important that you understand the associated costs. If you don't have a good understanding of the charges, you may be in for an unwelcome surprise. Till now we have seen 5 key cloud characteristics. Now we will see cloud deployment models. Cloud deployment models. The way the cloud is used varies from organization to organization. Every organization has its own requirements as to what services it wants to access from a cloud and how much control it wants to have over the environment. To accommodate these varying requirements, a cloud environment can be implemented using different service models. Each service model has its own set of requirements and benefits. The NIST definition of cloud computing outlines 4 different cloud deployment models: public, private, community, and hybrid. We give a brief overview of these here. They are covered more in depth in a later video. Public cloud. When most people think about cloud computing, they are thinking of the public cloud service model. In the public service model, all the systems and resources that provide the service are housed at an external service provider. That service provider is responsible for the management and administration of the systems that are used to provide the service. The client is only responsible for any software or client application that is installed on the end-user system. Connections to public cloud providers are usually made through the internet. Next. Private cloud. In a private cloud, the systems and resources that provide the service are located internal to the company or organization that uses them. That organization is responsible for the management and administration of the systems that are used to provide the service. In addition, the organization is also responsible for any software or client application that is installed on the end-user system. Private clouds are usually accessed through the local LAN or wide area network, WAN. In the case of remote users, the access will generally be provided through the internet or occasionally through the use of a virtual private network, VPN. Next. Community cloud. Community clouds are semi-public clouds that are shared between members of a select group of organizations. These organizations will generally have a common purpose or mission. The organizations do not want to use a public cloud that is open to everyone. They want more privacy than what a public cloud offers. In addition, each organization doesn't want to be individually responsible for maintaining the cloud. They want to be able to share the responsibilities with others. Next. Hybrid cloud. A hybrid cloud model is a combination of 2 or more other cloud models. The clouds themselves are not mixed together, rather, each cloud is separate, and they are all linked together. A hybrid cloud may introduce more complexity to the environment, but it also allows more flexibility in fulfilling an organization's objectives. Till now we have seen cloud deployment models. Now let's jump into cloud service models. Cloud service models. When you look deeper into what services can be provided by a cloud implementation, you start talking about cloud service models. The NIST definition of cloud computing outlines three basic service models: Infrastructure as a Service, IaaS, Platform as a Service, PaaS, and Software as a Service, SaaS. We will briefly cover these models here, then cover them more in depth in a later videos. Infrastructure as a Service. Infrastructure as a Service, or IaaS, provides basic infrastructure services to customers. These services may include physical machines, virtual machines, networking, storage, or some combination of these. You are then able to build whatever you need on top of the managed infrastructure. IaaS implementations are used to replace internally managed data centers. They allow organizations more flexibility but at a reduced cost. Platform as a Service. Platform as a Service, or PaaS, provides an operating system, development platform, and/or a database platform. PaaS implementations allow organizations to develop applications without having to worry about building the infrastructure needed to support the development environment. However, depending on the PaaS implementation you go with, you may be limited in what tools you can use to build your applications. Software as a Service. Software as a Service, or SaaS, provides application and data services. Applications, data, and all the necessary platforms and infrastructure are provided by the service provider. SaaS is the original cloud service model. It still remains the most popular model, offering by far the largest number of provider options. That's it for today. I hope you understand it well. Thank you for watching.